Hello everyone, hope you are doing good and welcome back to my channel. Today we are at problem of the day 14 for the January month, Geeks for Geeks, and it's a very interesting question in front of us. See, there could be many ways of doing it. I will tell you the way which I thought of, and I feel that definitely I this was a very satisfying solution for me. And if you could code in this way, and definitely it will surprise the interviewer as well. We'll show that what it is, but let's see what the question is. Question is find duplicate rows in a binary matrix. Okay, so the question tells most of the thing, but still we will go for the detailed question. It's a medium level question and see what the question is. So the idea here is see the exam, the input first. You are basically given a matrix. What is a matrix? Basically, it is a 2D structure. Okay, it's a 2D structure, and it's clearly mentioned that it's going to be a binary one. So only ones and zeros will be present. So what you have to do is you have to find out the rows which are already appeared once. Okay, for example, see here, if you see this example, they are saying that row 1 and row 3 are a repetition. Okay, as you can see, row 1, which is this one, is a repetition of the already existing row 0. Okay, similarly, if you proceed further, this is row 2, and the row 3 is a repetition of the row 2. That's why we have to output the row numbers uh, as per the 0 index. We have to output the row numbers which are reoccurring. Okay, as simple as that. So I will just go through the question once. Given a Boolean matrix of size R into C, okay. Boolean, I already mentioned what is Boolean. Boolean means zero and ones, okay. So only zeros and ones will fill the content of the array, okay. Given a Boolean matrix of size R and C, R cross C, where each cell contains either 0 or 1, find the row number, zero based, they are talking about zero based row numbers, okay. That is zero based index. Find the row numbers of row which already exist or are repeated, okay, which already exist or are repeated, and that both mean the same, okay. So that's what we have to do. It's a very simple question, but remember that see there what they're asking, and in my solution I can be very proud and say that we are doing in a much better space complexity than this, okay. My space complexity is much better than this. I will explain the same. In my case, the space complexity is going to be O of R. I will explain that how it works. And yeah, we are doing in a much better way than this, okay. Now let's see what I am doing. So before that, let me quickly tell you something. See, whenever you have these things like binary now, you should have at least something coming to your mind. What is binary? See, what came to my mind is this, okay. For example, if I talk of a decimal representation, sorry, the binary representation like this. So can you quickly tell me what this number is? It's as I have already written, it's 7, okay. How that works? See, it is 8 4 2 1, okay. Their place values are 8 4 2 and 1. So in this case, we don't have 8 because it is 0 in that place. So 4 2 and 1, okay. What is 4 plus 2 plus 1? It is 7. So the idea here is this particular place is 2 power 0, this particular place is 2 power 1, and this particular place is 2 power 2. Similarly, this is 2 power 3. So that's what we are doing. So one thing is very clear in my mind is that, see, whatever be the representation, okay. See, this is what we are doing here actually. We are mapping a binary representation with a decimal number. And by the way, it's not like if you have ones in any place and then still you will get 7. If the position of 1 changes, let there be 3 ones out of the 4 places, but even if the position of the 1 changes, this answer will change. So one thing is very sure, if I want to if I have a sequence like this, and if I can convert it to a number 7, then I can be definitely sure that it will have this representation only. There is no other representation like this, okay. If you follow that rule, that's what I'm going to do here for finding the duplicating rows. So what I will do is, see here, I will take the binary, that is, yeah, I will consider this as the binary representation of a number, and I will find that corresponding decimal number. Okay, then I will associate it with the row number. Then next I will check if any other row has similar decimal representation. That means it's a repetition, and in that case we'll have to print the row number. As simple as that. I hope you have understood what I'm talking about, and let's see how to code it. See, I will need a set here. I don't need any dictionary. See, normally I will use dictionaries, but in this case, okay, we just need to find out if a row is repeating or not. Okay, as simple as that. We don't need to tell the in the answer that to which row it is repeating. Okay, that is not needed here. We just need to tell whether it is repeating or not. So we just need a set for that. Okay, and as usual, we will have an answer because we'll have to return the repeating row numbers in a list. Okay, as simple as that. So what I'm doing, this is I'm going to the rows. Okay, for each row it will go. Remember, see, one thing I will tell you about Geeks for is that, see, though they have mentioned R cross C, but here they're giving M and N. Okay, M and N. How to understand that? See, this is the row. Okay, the idea here is you will have this many number of rows. Okay, similarly, this is the number of columns. As simple as that. So I will go through each row. Okay, I is going to be my that is row number. I is going to be my row number for each row. I will start with the sum 0. Then I will go to the corresponding elements of that row. Okay, for j and range n. Okay, that's what it is. So what I'm doing now, See, for each element, okay, this is the element, by the way, this is the element. What I'm doing, I am multiplying it with its corresponding. See, this is what is decimal conversion, right? How we convert binary to decimal. We multiply the given thing to the its place value. Okay, what is that place value? 2 raised to power that thing. Okay, that is what we are going. I hope you remember this. See, this is what it is. For if you talk about this thing, what is this? This is 2 raised to power 2. Okay, so 2 raised to power 2 into 1. Okay, as simple as that. So that is 4 into 1. That's what I'm doing here. I am multiplying that particular value, which will be either 0 or 1. This is either 0 or 1. I am multiplying them with its position value, which is 2 raised to power something. Okay, and what's that something? That will be dependent on its position, which will be j in this case. J will decide what will be the position of that array. Okay, what is position of that number, the binary number. And finally we'll add it to the sum, and finally we'll check if this sum exists in a. Okay, already this sum exists in the given set. In that case, I will append I will in the answer I will append the row number I. Okay, because row I is repeating. Okay, if that doesn't appear, then we will add it to the set. Okay, that's simple as that. And finally we return the answer. So let me quickly run this and show you if it works or not. As you can see, we are getting an expected answer. I have already submitted this solution and it really works. So I hope you understood what I'm doing here exactly. See, if you talk about the space and time complexity, actually, see this I agree. Then yeah, in this case it will be there for, because if you need to even go through each element, okay, you need this much time complexity. Okay, you will need two loops at least, one side another. Now coming to the space complexity. Now can you quickly tell me how much maximum space it will apply? Okay, so even if all rows have a different at the sum coming, that is, let's say all of the rows are distinct, so what will the max will that this particular thing will take, this particular set will take? So it will be O of r. Okay, what is r? R is the row number. Okay, if each row is distinct, it will have r distinct values, as simple as that. Okay, now if you talk about the answer, though, see, in normal case we should not consider this time complexity of the answer. Okay, that is, this answer is to be returned. Okay, this is not involved in our computation as such, because they are asking it in a list form, we are written in a list form. Okay, so still let us consider it. See, answer is, we have what we have to return in the answer. We have to return the answer, the it is row numbers which are repeating. Okay, let us say all the rows are repeating in the worst case. Okay, it will be the worst case. All the rows are repeating. So how much it will be? In the worst case, it will be OFR. Similarly, this also will be OFR in the worst case. But remember one thing: when this is this A of set is OFR, this will not be OFR. Okay, try to understand this fact. If everything is repeating, then it will have only one value. It will be O of constant. It will have only one value. This set will have only one value. Okay, so when this is O of r, this will be only one value. It will be there, and when this is O of r, that is all rows are distinct. Okay, then here no value will come, because we have to return only the repeating ones. Okay, so both of them will not happen at the same time, but still, even if we consider the worst case, it is going to O of r only. Okay, so in my case, the space complexity is going to be O of r. Okay, so what they are asking here, they are asking of r cross c. Okay, r into c, but I've already shown that no, we can do it with O of r itself. So that is optimization, which will be of great value if you can do the same in a interview setup. What they expect, you are going beyond the expectations. Okay, as simple as that. Now coming to space complexity, yeah, I agree that space complexity in my case also is the same as what they're expecting. It is O of r into c. Okay, because for even for going through each element, we'll need at least this much space complexity. Okay, as simple as that. So yeah, fine. That was this answer. This was very good question, and it appeared in Microsoft interviews as per Geeks for Geeks. And yeah, as I have mentioned, this is the one. Now let me tell you one thing quickly. If you are going to trace it how it works, remember one thing. Here we are starting from right to left. Okay, so this is the first thing, which will be 2 power 0, and then we'll go to 2 power 1 here, then 2 power 2, and like that. Okay, but in my answer, what I've done is that I am proceeding with the j value itself. So how this works actually? So what will happen is, this 0 will be treated as 2 power 0, this 1 will be treated as 2 power 1, and so on. So idea here is, see, this I have only written to tell you the idea. Okay, what we are doing here, we are mapping a binary representation with a integer. Okay, and that it's remember, it's not like for any representation 7 can come in. Okay, only for one particular representation 7 will come. Okay, as simple as that. So that's what I'm trying to prove, and I'm using same logic here, though it's not the same, totally same. Okay, here we are having the place value started from right to left, but in this case we are starting the place value from 0 to that is left to right. Okay, because j starts from 0 to right, as you might be knowing. When we go from left to right in any array, the index starts from 0, and it proceeds further and increments further. That's what it is. So if you want to trace it out, I will give the solution in the comment also. You can maybe include some print statements, and you can check further. So yeah, friend, that was all for today. I hope you liked my solution. This was, I felt that yeah, if this question comes and if I'm able to code this kind of solution, I am definitely confident that I have given my best. As simple as that. I don't know what Geeks for Geeks has given the solution for this, but I feel this is a very very efficient approach, especially considering the fact that they are expecting something even more. Okay, if you see, whenever you see the term binary, see, these things would come to your mind. Okay, why this thing came to my mind is because I heard the term binary. Okay, and we are talking about repetitions here. I know that once I include this technique, there is only one way to achieve a number, a decimal number, and that can be done only through one particular binary representation. So that way it's very easy for me to check if same representations come appearing again. So yeah, friend, that was all for today. If you like my efforts, if you like my videos, or if you want to give any suggestions, please do so in my comment section. And if you like my efforts, please subscribe to my channel. That gives a lot of motivation. So yeah, friend, that was all for today. See you tomorrow. Thanks a lot.